Is it visible to you?
Yes, sir.
Okay. So what we have discussed, I just take a quick review of this one till all others are joined us. So we have taken one example in which we have seen. Okay. So first of all, we have discussed about the energy and power signal. The energy signal is a signal which has a finite energy, right? And how we can define the energy? So energy can be defined by this equation. This is equations. It's an integration of absolute value of g of t whole square. So it is area under the curve g of t whole square. Then we have defined the if energy is a finite, then and then the signal can be considered as a energy signal, right? And to be the finite, to be the energy as a finite, it is essential that as the time approach to infinity, the amplitude of the signal approach to zero. It means it should have a finite duration, and if any signal have a finite duration, it has a finite energy. Then we move to the another signals. If the signal is a periodic, so its energy is infinity, and that we consider that signal is not a energy signal. Then the measure of such kind of a signal is known as a power. So how we measure the power? The power is can be defined as a integration of energy, integration of the signal for one time duration 0 to 0, or sometimes you may represent as a minus t0 half to plus t0 half, and it is divided by the time duration or period of the cycle t0, and then t approach to infinity is defined the signal is approaching to infinity or it has an infinite duration. So if such kind of a signal which is periodic in nature and it has infinite duration, we can find the power as a true measure rather than the energy. And for that one, what we need to do, we have to find the energy per cycle and it is divided by the time, so that we are getting the power. So power is the energy per unit time, and the unit of the energy is joule, and so the unit of the power is known as a watt. And the relationship between watt and joule is that 1 watt is equal to 1 joule per second, because the energy is divided by the time, so it is joule per second that we get as a power. So this is what we have discussed earlier, and then we have discussed the any signal may be either pole as a energy signal or power signal. You rarely find any signal which has a both the thing. Sorry, you never find any signal which is energy signal as well as the power signal. Your signals may be either as a considered as a energy signal or power signal, or the signal or other signals are neither energy signal nor power signal. So we may have a three category of this one. We have taken one examples and then elaborate this topic further, and that we understand this topic. Then we have learned about the examples. Two examples have been presented. One example is the example of energy signal, the first example, in which if you see this, observe this signal, so you will find as the time approach to infinity, the amplitude approach to zero, that is exponentially decreasing signal, and with the rectangular signal. So we have find the energy of the signals, and the answer we have obtained was a 8 joule. Right? So this part we have already covered. The second example I have given you is a RAM signal, which is a periodic in nature, and the signal is periodic in nature. So obviously it is starting from minus infinity and approaching to plus infinity. So we cannot find the energy of the signal. We can find the power of the signal, and if we find the power of the signal, so it is have to find the energy per cycle. We have to find the energy per cycle divided by the time duration of one cycle. And then if you solve this one, that we have find the final answer as a 1 by 3 watt. Then we have given you a three examples to solve. The first example in which the equations are given, or signal is given as a c of t is equal to c cos omega 0 t plus theta, and the answer which is provided is c square by 2, right? Some of you have solved this one, or maybe all of you have solved this, I don't know. The second example of g of t is the second example is g of t is represented as a c1 into cos omega 1 t plus theta 1 plus c2 into cos omega 2 t plus theta 2. And if you solve this, you are getting the power of the signal is c1 square by 2 plus c2 square by 2. Right? I think most of you obtained the answer. And the last one, g of t is equal to d into e raised to j omega 0 t. So exponential, if you find the exponential is square of e raised to j omega 0 t, so it is 1, right? Because it's a cos omega 0 t plus j sin omega 0 t. So absolute value of this one is square root of cos square omega 0 t plus sin square omega 0 t, and that is 1. So this one would be a 1, and then we finally answer out with the power of this signal is simply the amplitude square. d square, absolute value of d square, right? So all these examples I have given you as a homework, and I hope you have solved this example. Then we move further with some useful property of the signal. There are three property can be elaborated on time axis. One is the time shifting property, time scaling property, and time reversal property. Time shifting property is related to shift the signal either right side or left side. If we are shifting the signal right side, so it is known as a delay version of original signal. And if we shift the signal from left side, so it is known as a advanced version of the original signal. So if our signal is a g of t signal would be like this, and if I move the signal right side by the 2 point, so it is considered as a g of t minus 2. This negative sign is indicating that this is the signal is a right shifted signal, right? Now, contradictory to this, if this u of t signal is lap shifted by some point, so it is considered the signal considered as a g of t plus 2, right? Where the plus sign here it indicates the signal is advanced by 2, right? Shifted left side. Then we move to the time scaling property, and here we can have a two variants. Compression, we can compress the signal in time domain, or we can expand the signal in a time domain. So if the signal is compressed in a time domain by some factor, so it is directly multiplied with the t. For example, here the g of t signal is represented as a triangular signal, and if the signal is compressed by factor 2, so it is known as a g of 2t, right? It is compressed by 2. So if the compressed by 2, so this earlier, whatever the amplitudes is available at minus t is now available at minus t half, right? And whatever the amplitude is available at t is now available at plus t half. So here this amplitude are shifted at a amplitude is shifted at minus t half and plus t half. So signal we can say compressed by the factor of 2, right? And the similarly, if we expand the signal by 2, so that we need to divide the in expressions we need to divide it. So if g of t by 2, it means the signal is expanded by the factor 2. So if earlier signal was expanding from minus t to plus t, is now the new signal which is new signal as a g of t by 2 is expanded by the factor of 2. So it is now explore from minus 2t to plus 2t, right? Then we have discussed this one. By generalize, we can say the signal after the scaling, the g of t signal a is to be converted as g of at, where a is known as a either compressed scaling factor, right? So this a is known as a scaling factor. Now, as per the value of a, we can conclude either the signal is compressed or the signal is expanded. So if we assume that a is larger than 1, we assume that it's positive, huh, always. So this we are assuming larger than 1, and we always consider that a is greater than 0, huh? This is also there. So if a is larger than 1, then we can say the signal is compressed by the factor of a, right? Compressed by the factor of a for a greater than 1. And if the signal is expanded by some factor a, so we have to find the a. And if a is sorry, here there is a mistake. If a is less than 1, then we can say the signal is expanded by this factor of a, right? So if g of 3, we taken an example, g of 3t, it means the signal is compressed by the factor of 3, and g of 0.2t, it means the signal is expanded by this factor, right? Now we will take a look of some examples today, but before that, the third property is a time reversal property. If we are shifting the signals with respect to zero axis, y axis, right side or left side, so this is known as a reversal of signal. And after reversal of signal, whatever the amplitudes was available earlier at the case of t is equal to t1 is now available as t is equal to minus t1, or whatever is available at t is equal to minus t1 now appear at t is equal to plus t1. So this is just like as a flipping of your signal from right to left or left to right. It can be applicable for both the side. So this is taken one examples of the signals, which is g of t is originally like this one. Now after the flipping, it becomes a g of minus t, and after g of minus t, whole the amplitude which are available earlier at a minus t value, or minus t1 minus t2, like the minus t1 minus t2, is now available at a t1 and t2, right? So it is plus. So this part we have covered. And now we can solve some more examples with whatever the detail insight you have obtained with some experience by putting some efforts to solve some examples which I have given you as a homework. So I think you have a sufficient confidence to solve some examples, and we will solve some examples. So we become say master of this. Examples are very important things. If you solve any examples, that our theoretical concepts become say strong. So looking to that one, today we will solve a few examples based on whatever the concept we have learned so far. So there are six examples that have been presented on the screen, in which you have to find the power in RMS value. RMS value is a root mean square value. So if once we find the power of any signal, and if we take the square root of that one, so we are getting the root mean square value, right? And these are the very important examples. Some of the examples you may consider for a GATE examination, right? Because in most of the times, if you are very good, fundamentally you are very good, very strong, right? So of any subject, so you can easily crack the GATE examination. GATE examination will never check your memory, it will check your fundamental concept. That is very important. If you pass or if you get the good marks with only the memory, right? Exam is not here. What India in India we have a problem with, most of the exams are memory exam, right? But we take care in these subjects. I will ask you fundamental questions, but this is not the case. If somebody is very is ranker in your class, right? But if he pass all the exams by using their memory only, so it is not actually good things. You need to develop your fundamental concept, right? If you have a strong fundamental concepts, then you will develop further, right? In any of the education systems, those students who are coming out with a good fundamental concepts will go ahead, right? This 4 years or the boundary of the GSET is not only the learning factor for you. The whole life is learning factor for you. So if you go outside of this one, you will find the different environment. So in those environment, your fundamental concepts will be helpful, right? If you pass the GATE examination, if you correct the interview, so everywhere the fundamental concepts are useful. So I urge you, you are in a second year, so you have a long span, still 3 years are left for you. In every subjects, you try to develop the strong fundamental concepts, right? And try to develop a strong fundamental concepts. Ask a multiple questions for yourself. Try to solve out this and develop and grow in this way, right? Rather than to mug up the things. Okay. So now, uh, uh, this was the message from my side, and now we directly came to the part of the subject. So here we have to find the power and RMS value of the following signal. There are six signals are presented in front of you. I hope the things are visible to you, and there are very less lacking, right? Whatever I'm drawing the line and whatever I'm speaking to you, there are very less lacking, and you are almost receive everything in a synchronization, right? Okay. So now let's start with the first example. The first example here is 10 cos 100t plus pi by 3, right? So if you solve this example, if you solve this example, that is given as a g of t. This is first example, which is given as a 10 cos and 100t plus pi by 3, right? 100t plus pi by 3. So actually, I don't need to solve these examples, because earlier if you have already solved this example, and in this example you have solved if any signal is a c is a amplitude, c multiplied by cos omega 0 t plus theta, then finally the answer of this one is a c square by 2. Right, c, it's amplitude square by 2. It's amplitude square by 2. So I don't think this you need to solve, but for an example, this is your first example, so I would like to solve this, right? Rather than this one, if it is something like this one, g of t is something like as a c cos omega 0 t plus theta, right? Anything. Omega 0 may be any value, theta may be any value, c may be any value. So you always turn out with the answer, the power is a c square by 2. How this equation comes? So let's consider this thing. The power Pg is basically known as a, the power Pg is how you define this power. What is the equations of power? So it is limit t approach to infinity, right? And what is 1 by t 0 to t, this is I think t0 g of t whole square dt, right? So that way you may consider. So now if I drop this one for a simplicity purpose, so this equation can be reduced as a 1 by t0 0 to t0 g of t absolute value square dt. Now g of t is already available with us. It's a c into cos omega 0 t plus theta. C may be any amplitude value, right? C is the amplitude value. So if I replace this equation with this c square into cos, c into cos omega 0 t plus theta absolute value square dt, right? So what finally we are getting over here is 1 by t0 0 to t0 c square cos square omega 0 t plus theta, and we need to find the differentiation of this, integration of this. So if you solve this one, so cos square omega 0 t, if roughly we can simplify as 1 by t0 0 to t0, and here it's a c square 1 minus, how you define a cos square x is 1 minus cos 2x by 2, so that is cos 2 omega 0 t plus theta, right, plus theta by 2, and with respect to t, so it's a dt. Now, if I solve this one, so we are getting here, there are two parts of this integration. The first part is 0 to t0, I divide, so c0 multiply here, so it becomes a c square. So c square minus c square into cos 2 omega 0 t plus theta, right? This is the part. And if I divide by 2, so it is like this. So now these equations can be break down in a two part, 0 to t0 c square by 2 dt. This is the first part, the term number 1. This is your term number 1, and this whole is your term number 2. So as per that one, this is the first integration, and the second integration is minus 0 to t0 c square by 2 cos 2 omega 0 t plus 2 theta, right, into dt. Now if you what this indicate the area. No need to go further, right? Because if you go further, by converting cos into sine, take the integration of cos would be sine, and then apply the limit. But you consider what is this, so it is the area of cos, area of cos theta, area of cos theta, theta may be or cos phi, right? Phi means this whole part. Phi is what? 2 omega 0 t plus 2 theta, right? This is my phi. So if you find the area of any cosine signal, so that is 0. Why? Because cosine signal is like this signal, right? This is a one cycle, this is one cycle from here. So what does happens here? There are some positive portions, there are some positive portions. How much? 0 to t0 by 4, right? 3t0 by 4 to t0. So there are some positive portion, and there are some negative portion also, there are some negative portion also. But if you find the area, we have to take the integration. So the area of positive area in a cosine is equal to the negative area, right? So they will cancel each other, and finally if you find the area by taking the integration of any cosine and sine signal, so it would be turn out to 0. This would be turn out to 0, right? So area of cosine of any cos 5, it would be a 0. And what is the area? So area is simply integration of that one with respect to minus infinity to infinity, right, d phi, and that would be 0. So here the same thing happens. It's a cos 2 omega 0 t plus 2 theta. But if you assume 2 omega 0 t plus 2 theta as a phi, so that is the area covered by the cos phi, and that would be a 0. And this is not applicable for cos if you consider the sinusoidal signal. So sinusoidal signal has also the similar things. They have a positive area from 0 to t0 by 2, and from t0 by 2 t0 they have a negative area. So if you add up the sine phi, that would also be a 0. So finally, if you are getting the integration of cos and sine for one cycle, right? One cycle, that is important for one cycle, because if you consider 1.5 cycle, that the scenario would be different. They have more positive area. But if you are considering only a cycle, one complete cycle, so it have equal positive and negative area, and they will cancel each other. So for understanding point of view, we can say this part, this term, the second term would be 0. So what we left with is the only first term. What we left with is only the first term. So area, so that we can say this term would be a 0, this would be a 0, right? So what we left with is we left with only the first term 0 to t0 c square by 2 dt, right? Now c square by 2 is a constant, so what we left with is 0 to t0 t into dt, sorry 1 into dt. And what is the integration of 1? That is the t. And if you apply this limit 0 to t0 c square by 2 t0, then we can say that is c square by 2t0 and apply the limit t0 minus 0. So that is t0, t0, t0 will be cancelled, and then the final answer that we obtain over here is c square by 2. C square by 2, right? So now the question is what? We have to find the power of this one, right? What is the power of this one? So our example is not that, but our example is we have to find the power of 10 cos omega 0 t plus pi by 3. So it is a similar kind of example. Rather than c, we have now 10, right? And all other parts of the body or body of the equations remains the same. So now what is the sorry, this is my g of t. So now you can tell me what is the power of this signal. What is the power of this signal? Simply we can say the power of this signal we can easily consider as a c square by 2, like that one. And c in our case in this example is 10, so it is 10 square by 2. And if you find it's a 10 square is 100 by 2, so it is 50 watt that we have found the power of the signal. And if we find the RMS value of the signal, so it is exactly square root of PG, right? It is RMS value is a square root of power, and that the square root of a 50, you may identify some numerical value of this, maybe 7.1 or something like that roughly. So this is one example, right? Okay, now we have a second example. In the second examples we have to find the power of this equations. Which equation is this? This equations we have to find the power of this one. I just copy it and paste here. For second one, what is the second one? This one, right? So we have a this signal. With this signal is given as a g of t signal, right? It's known as a g of t signal. So now can you correlate this equation with earlier equation? G of t is equal to c1 cos omega 0 t plus theta, or maybe cos or sine, or c2 sine or cos doesn't have any sense. Cos omega 0 t plus theta 2, right? So this is similar equations, because this one and this part, it's on, this is omega 0 and this is theta 1 part, right? Here this is omega 2 and this is theta 2 part, so looks same, almost the same. So now what we have find earlier, whatever the examples which I have given in a homework, that if such kind of a signal is a PG, so if you solve these examples with the same way by taking the square of this, so you are getting cos square omega 1 t plus sine square omega t theta t plus 2 time cos and sine. And then if you solve this, that finally comes out to 0 middle term, right? And then we have only the first term's amplitude square, so it is the first term c1 square by 2, and the second term amplitude square, that is a c2 square by 2. We left with this only. This part you can do it your homework by looking to the time constraint, that I'm not solving this, but if you solve this as a homework part, so you can say if there are cosine and sine terms are added together, so their power is actually the amplitude square in individual amplitude square. So its amplitude is this first term is this, just term number one is a C1, and for term number two is a C2. So what is the power here? It's a power of amplitude square of individual terms. So it is C1 square plus C2 square. And in our case, whatever the examples has been given is a 10 cos 100t plus pi by 3 plus 16 sine 150t plus pi by 5. Right? This example. So if you find the power of this one by considering what is now C1, this one is a C1, right? This 10. And what is the C2? 16 is our C2. 16 is our C2. So if you find the power, so that is of 10 square plus 16 square, right? And if you solve this, so you can find 10 square is 100 by 2, and 16 square is 256 by and that is by 2. So 100 by 2 is 50 and 256 is 128, right? If I'm not making mistake, it's a 128. So then you, if you add up, so that becomes a 178. Okay, so you can find out the answer of this one, the second example. Okay, I think you understand this thing. If you are in doubt, you let me know at this point. Now, otherwise, I will move to the third example. So now we will move to the third example. So in third example, what we have given this 10 plus 2 sine 3t into cos 3t. So let's take a copy paste of this one, and let's place here, right? So this is given, and this one is our g. This signal is our signal g of t, right? Okay. So now this one is given 10 plus 2 sine 3t into cos 10t. So we have to convert them into individual component of sine and cos. If we convert them in individual component of sine and cos, then we apply any of these equations which we have learned earlier. Uh, so the first part is that we need to consider it as a, or we need to separate it as an individual term, right? Individual term. So let's multiply this function with the cos. Cos 10t is multiplied with both the terms. So it is, the first term is 10 times cos 10t, right? And the second term is 2 times of sine 3t into 3t into cos 10t. Right. So okay, now first term is simple, it's a simple cosine, so we can have amplitude, what's the power of first term is amplitude square, c square, right? It's just like a c cos omega 0 t plus theta, where theta is 0. But the second term is not look similar. It's a bit tricky because there are two terms, cos I means there are two carriers, sine and cosines are multiply. So we apply these equations. What is the equations? If something is a 2 time of sine and theta 1 into cos theta 2. So how we can represent this equation? That is simple, sine of theta 1 plus theta 2 plus sine of uh, theta 1 minus theta 2. That is very simple. So as per this one, if you apply here, so the first term remains as it is, 10 cos 10t, right? But the second term is a 2 sine 3t plus, yeah, 2 sine 3t into cos 10t is multiplied in a two parts. So first part, they both theta 1 and theta 2 are added. So 3t plus 10t, we are getting 13t. So that we are getting a sine of 13t, right? This is related with this one. But the second, in which theta 1 minus theta 2, so that is minus 3t minus 10t, so it's a minus 70. So it's a sine of, but sine of minus theta is minus sine theta, so that is of sine 70, right? Okay, so we have applied this equation. Now the thing looks very easy, right? So we have it, this three terms are there. This one is known as a term number 1, this one is known as a term number 2, and this one is known as a term number 3. Okay, so what we apply now, we can have, if apply this equation, but there are three terms, so we can have a power is c1 square by 2 plus c2 square by 2 plus c3 square by 2, means amplitude square of first term by 2 plus amplitude square of second term by 2 plus amplitude square of third term by 2. So very nicely we can correlate it with this. The first term power is a 10, so it is the first term power is a 10 square by 2. First term amplitude is 10, second term amplitude is 1, so the second term power is 1 square by 2, and the third term is an amplitude of minus 1, so its power is minus square minus 1 square by 2. So finally we are getting here 100 plus 1 plus 1 by 2. Exactly, right? So it is 100 plus 1 plus 1, so it is known as a 102 by 2, and that is finally we are getting the power is a 51 watt, right? I think you are getting this. Okay, so now we will move to the fourth example, and I hope the fourth examples I'm expecting from your side, right? You are well aware about this, and you are now I think understanding the concept very well. So I am expecting this fourth one you can solve by yourself and you let me know the answer. But if there is some problems that I will explain it in a further detail. But now considering this fourth examples, you try to solve by yourself. If you are not in pain, then you try to solve this example by yourself, right? Most of you, I think, have can do this example, g of t. So what is the answer? Can anybody? 10 cos 5t into cos 10t, right? You need to solve this. So how you solve this? You can take the 5 as a common and then 2, right, multiply with the cos 5t and 2 cos 10t. Okay, now solve this and let me know the answer. I will give you a 2 minutes for this. Okay, anybody from your side can answer out this? Hello, anybody of you can solve this? What is the power? 5, right? 2c plus c, cos plus cos. So that we have a cos x plus theta plus theta 1 plus theta 2, theta 1 minus theta 2. So we can say that is a, yes. What is the answer?
25.
25 by 2. 25 by 2, right? Yeah. So that is the 5 time cos. I think 25. Sorry. Yeah, but there are two terms are there, no? Sorry. So that is 5. That is 5 time cos 5t, right? So this is your C1 and this is your C2. That is g of t. So 25 is the right answer. PG is basically C1 square by 2 plus C2 square by 2, right? So that is the 5 square by 2 plus 5 square by 2. 2 times there are 5 square by 2, right? So 25 by 2, 25 by 2, and then finally it is 25 volt, right? Good. You are learning. So now the next example is with the similar. This examples you can solve by yourself. Huh? This is very similar that we have solved. But now the next example is the fifth. I skip this example. I omit the example of a fifth, right? Because this is very similar example. Now we directly move to the sixth example, e raised to j alpha t into cos omega 0 t, right? E raised to j alpha t into cos omega 0 t. So I left with the fifth example, but solve the sixth example. So g of t is e raised to j alpha t into cos omega 0 t. Now how you solve this example, right? So everybody know that if anything like as a cos theta, right? Anybody like as a cos theta, that can be represented as a e raised to j theta plus e raised to minus j theta by 2, right? So there is a cos omega 0 t where theta is, this is a theta, right? Theta is omega 0 t. So how you represent as per this equations, e raised to j theta plus e raised to minus j theta by 2. So we can represent this one as a e raised to j alpha t into e raised to j theta omega 0 t plus minus theta means e raised to minus j omega 0 t by 2. We can represent in this form, right? By 2. So now this is the first part and this is the second part. So now you multiply e raised to j alpha t both side. So e raised to j alpha t into e raised to j omega 0 t by 2. This is your first term. The second term e raised to j alpha t into e raised to minus j omega 0 t by 2. This is your second term. So now your first term is e raised to j alpha plus omega 0 t by 2, right? 1 by 2 I can say. And here it's a 1 by 2 e raised to j alpha t minus alpha minus omega 0 t. So we can say it's alpha minus omega 0 t. Now we need to find the power. So what we earlier find, if anything is like as e raised to j is e raised to j omega 0 t, and if you find the power, right? So what happens basically, if you find the power is basically happens minus infinity to infinity 1 by t 0 d square into e raised to j omega 0 t whole square, right? And e raised to j omega 0 t is basically absolute value of this one, means e raised to j omega 0 t is we can represent as e raised to j omega 0 t is simple represent as a cos omega 0 t plus j sin omega 0 t, right? Is j sin omega 0 t. So if somebody are interested to find their absolute value, right, absolute value, so that is basically considered as absolute value of cos omega 0 t plus j sin omega 0 t. And you have already explored this concept earlier in mathematics. If something is in form of a x plus y z, right, this is your x and this whole is your y, right? So if the magnitude is a square root of real part plus imaginary part, as per this one, this similarly applicable here also, the imaginary part and real part square root of real part is cos square omega 0 t plus imaginary part is j sine omega 0 t, so its coefficient is sine, so it's a sine square omega 0 t, and cos and sine square of cos square and cos square theta plus sine square theta is 1, that is 1, and that you are finding 1. So if you are taking the absolute value of any exponential function, that is in general sense we can say, if you take the absolute value of any exponential function, that would be turn out to 1, right? So here we are applying the same thing here, so that's why if you are finding amplitude is 1, so we left with 1 by t0 minus infinity to infinity d square. I mean, so this is not minus infinity, huh? You consider it is for one cycle, so it is from 0 to t0. So that is 0 to t0 t square. It left with only d square, right? It left with only d square. And if you find the d square as a common, so the left with 1 by t0 and integration of 1 only. And that is the t0, right? t0 minus 0 and t0 will be cancelled out. So finally, we're left with only d square, right? So we have already, I have already given this example in assignment, and in such cases, if something is d into e raised to j omega 0 t, so power of e raised to j omega 0 t will be turned out to 1, and we're left with the power of this one is only the amplitude of this function as a d square, absolute value of d square. So as per this one, this is the similar example, right? So what is the power of this one? So if we go with the this part, if we go with the same things what we have learned here, we can see the power of this signal is the power of a first term, right? 1 by 2. So because here the power of this one exponential function becomes a 1. So what is the constant or amplitude is 1/2. So here as per this equation, absolute value of 1/2, but 1/2 is positive. So if you take absolute value, there also 1/2. So 1/2 to whole square, and the second term is also 1/2. So it's a 1/2, so 1/2 square. That will be turned out to 1 by 4 plus 1 by 4, and that 1 by 4 plus 1 by 4 is 1/2. So that is what, that is 1/2 what the power we have already obtained over here, right? So such kind of a more examples you will solve at a later stage, right? Such kind of a more example you will solve at later stage regarding the power and find the RMS value. So what is the RMS value here? So RMS value here is a simple, we can say, is a square root of 1/2, right? Okay, so I think that is sufficient for the examples of power and RMS value. Now we will solve some more example regarding the operation, right? Operation on the signal. So this is one example which is given, in which g of t is presented in front of you. This is our g of t, right? G of t is presented in front of you, and you need to find g of 3t, g of 3t. So first you let me know whether this is the operation of compression or expansion, then we will move further. Is it compression or expansion? Hello? Compression. By how much factor compression is there? By 3, right? So if we plot g of 3t, because if we have already defined, if something is a g of at, and if a does lies greater than 1, right? So we consider this operation is known as a compression operation. And if this g in g of at, if a is less than 1, right, less than 1 means a fractional value, so that is known as a expansion. So if we consider here g of 3t, where a is 3, right, this is a and a is 3, so that is greater than 1, so it falls in this category, and that means this operation we consider as a compression. So for that one, we can see g of 3t is a compression example, so we need to compress the signal by how much factor? 3, right? So how we can define g of 3t? We have to draw the same signal, but the points are going to change. This is the similar example. This amplitudes are at -1. This amplitude is at -1, and this amplitudes are at a 2. So these amplitudes are not going to change. These amplitudes are not going to change. That remains as a -2 and 1. And this is example of G. So what are these points? So if this everything is every time axis is compressed by factor 3, so whatever the points we have already observed at 6, they are available at 6 by 3. So 6 by 3 means 2. So this point is 2. Now this point is 12, right? Where this curve is meeting the x-axis line, 0 lines. So that is also divided by 3, so that we are getting here the point is 4. Somewhere here we have obtained some peak value as a 15. So now it is also divided by 3, because every time axis is compressed by 3, factor 3. So that becomes a 15 by 5, 3. And 24, this point is also divided by 3, so that becomes a 8. So this is example how we can represent the G of a 3T. So that shows that this is compressed by factor 3. Now there is another example in which the signal is given as a z of t, right? And we need to present as a z of t half. T half. T half means what you can say here. A is what? A is 1/2, right? A is 1/2, which is less than 1. So this is example of compression or expansion, obvious expansion, right? So that is the expansion example. And expansion by how much factor? So expansion by factor 2. This is a factor. So we can say it's expansion by factor 2. We need to expand this signal by factor 2. So we draw first the signal as it is. We draw like this, whatever it is, and all the points are expanded by factor 2. So if this one is a t half expanded by the factor 2, time axis is expanded by factor 2. So 0 point is remains as a 0. This point, which was -1, is now expanded by 2. So it is now getting a 2 minus, earlier it was -1, so now it is -2, right? Expanded by this -3 is now becomes a -6, and this point 1 is now becomes a 2, right? It's the way how we define the expansion by factor 2. Okay, the third example in which we have been given a g of t, and is example of a time reversal where we need to find a g of minus t, right? If g of minus t, so how we can do this? So in that case we can say this example are g of t, and we need to present as a g of minus t. So all these points which are appear at now minus t is now appear at a positive t. So it's just a mirror image. So we can say this -1 we are getting some amplitude 2, and -5 we are getting some amplitude at 1. So now this point is should be appear at 5, -5 after reversal, and this point of mine which is at -1, it should be appear at +1 after time reversal. So after time reversal we can have like this thing, uh, like this one. It's like a simply mirror image, right? This is our g of minus t. The points are this -1 becomes a now 1, and this -5 becomes now 5, right? That way you represent this signal. Now we can solve some more example, but I think fourth one would be the last one. There are one more. 4 and 5. So we will solve these examples and we will conclude this session. So this part have been covered. So if there are multiple operations are applied, right? For example, there are some shifting operations are there are some time scaling operations are there are some time reversal operations are there may be some mixing of this any two of them. So you generally follow this rule, right? The sequence we need to define the priority of this operation, right? So if you need to define this priority, so we can say the first priority is given to which operation? The time scaling operation is been given a first priority, sorry, time reversal has been given a first priority, right? Always this is priority one. The second priority is given if there are multiple operations are there. So first priority is given to the time reversal. The second priority is given to the time scaling. So second operation we will perform as a time scaling, and the third one is given as a time shifting, right? So these are the order of priority, right? If there are multiple operations that apply in all three cases that we have already solved or we have taken a look of, they have applied only single operation, so we don't have to worry about the priority. But if there are multiple such kind of operations are applied, we have to worry about the priority. So always the time reversal has the highest priority among these three operations, then it is followed with a time scaling operation, it is followed with a time shifting operation. So this is example. Fourth example have a two properties, two operations are applied, that is of g of 6 minus t. So how many operations are applied over here? Can anybody tell? Out of these three operations, how many operations are applied? There are two operations are applied. Which two are they?
Time shifting and reversal.
Yes, time reversal and shifting. So which one you give the extra priority? You first apply the time reversal operation, right? Time reversal operation, and the second operation is time shifting, because time reversal is the highest priority and the lowest priority is of time shifting. So first you apply the time reversal and then we apply the time shifting. So if we have to find g of 6 minus t from g of t, so first we draw the g of t as it is. We draw the g of t as it is. Now then we apply the first operation here, the part one, right? The part one, there are two parts. The part one we apply the time reversal operation. So first we apply the time reversal, so we produce a g of minus t first from g of t, and then we apply the time shifting. So if we produce this g of minus t first, so how this signal looks, over here. This point, this is totally shifted, so 6 12. So you can have it like this one, 6 minus 6 minus 12, right? You can have this one, and then it is move, and then it is move. So I think I need to replace it. uh, this after this looks like that one, right? Okay, so it looks like this. So this point is now becomes a minus 6, this becomes a minus 12, this 15, it becomes a minus 15, and this point it becomes a minus 24. So that is known as a g of minus t operation, right? Okay, now what we want to obtain, we want to obtain g of 6 minus t. So g of 6 minus t, it can be represented as this can be represented as g of minus t minus 6, right? It can be represented like this. They both are the same thing, because if minus sign is goes inside a bracket, it becomes a minus t, and 6 minus 6 becomes a plus 6. So this is similar operation. So what operation you are apply here is a g of minus t. Now you apply the shifting operation. So that is your part number 2, right? Part number 1, what you have applied, you have applied the time reversal operation, and in part number 2 we are applying the time shifting operation. So after applying the time shifting, what happens? The signal is shifted, right? So that is g of 6 minus t is actually g of minus t minus 6. So already you have g of minus t. So you shift the signal. This t is replaced with a t minus 6. So what happens? This is shifted left side or right side. If you are, it is minus here. It is a minus, right? This one is a minus sign.
Right
This one
shifted.
right shifted. So how many points? 6 points, right? So it means minus 6 is now shifted to where? This minus 6 is now shifted to 0, right?
Zero.
This, yeah, and this one is shifted to minus 12 is shifted to minus 6, and this one this one minus 15 is shifted to 6 points, so it becomes a minus 6
minus
minus
5.
9. Yes, minus 6 minus 9, and this minus 24 becomes a uh, minus 18, right? Yeah, minus 18. So this is the way how you represent the signal, right? So what you learn over here, if there are some priority, then you can have to give the signal first a time reversal property. If time reversal is the highest priority, then time scaling, if it is there, it is there. Here time scaling is not there, but if for time scaling was there, the second priority is of time scaling, and the third priority is of a time shifting. So now this one is given for your example, and then we conclude the session, right? So you consider this example as your homework example, your homework example, where the signal is presented like this. You note down by using a pen and paper, and what you need to sketch. So you need to sketch this four things. G of t minus 4. G of t minus 4 means the signal is shifted by port right side 4 points. So you don't need to have a multiple operations over here. It's a single operation, time shifting operation. The second is a t by 1.5. This is even a similar examples which we have shown earlier, but it's for your practice it is given. So t by 1.5 means you are expand the signal by some factor. How much factor? 1.5, right? You are expanding by 1.5. So that is even a single operations time scaling. The third is a g of 2t minus 4, right? So 2t minus 4, there are two operations. So how you perform this operation? The first operation is this operation. Which operation is this? Scaling operation, right? And another operation here is a shifting operation. So you can do this in a two part. In a part number one, what is the hint? Hint is that you have to first produce a g of 2t, means you compress the signal by factor 2. Now replace the t with a minus 2. So whatever the signal you have produced of g of 2t, now you shift by minus 2 only, because g of 2 inside a bracket t minus 2, it becomes g of 2t minus 4, right? So there are two operations are there. Operation number one, in which you compress the signal by factor 2, and then you have to shift the signal right side by the factor number 2. I expect this answer from your side. Now the last one is a g of 2 minus t. So what you produce here, there are again the two operations are there. First operation is the time reversal operation, and the second operation is the time shifting operation. So first you produce a g of minus t, right? This one is the first part. Then secondly, what you produce, you shift the signal right side or left side, right side, right? Because it's a t minus 2. So minus t plus 2, that becomes a minus t plus 2. So then you shift the signal right side by the amount 2. So I think this is fine, and I'm going to conclude the sessions. But be remain with me. I just joined from my desktop, and I will take your presence over there. Just wait for 2 to 3 more minutes. Okay. Have a nice day. Good day to all of you. Okay, is it audible to all of you?
Yes, sir.
Yes, sir. It is
Yes, sir.
audible.
Fine, fine. So it is only to take the presence because in this application there is a problem. So I cannot take the attendance from my iPad, right? Because there is no options are available. So I have to log in with the desktop. So every times we have this much delay, right? Okay. Anyway, I just take your presence. Just hold. Okay, done. Okay. So now you can leave the meeting. Have a nice day. Good day to all of you, and hope you solve all the examples and be remain parallelly with me, right? Small examples I will give at the end of each sessions, and I hopefully that you solve at your end, so you get the concepts very clear and you implement it by yourself. Okay, have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.